In this application, we have the Acuity AP820 laser line sensor, and this is the -60 model, and that means it's got a 60 millimeter depth of field, and then it starts at a 30 millimeter line length. And what we're going to do is we're going to look at measuring this black plastic material, and we're going to demonstrate that we can measure the height of it, and they've got some little artifacts on it, little nibs on it. We're going to show that we can measure those nibs. And as you can see, we have a hole here, and this is the table underneath it. And then I have a white ceramic Cera block that's exactly 1 millimeters. And what we're going to do is we're going to show that we can measure that millimeter step height, which will give you a good sense of proof of concept that we're measuring the target material. And also, as you can see, we're going to go from a shiny white to a wood surface to a dark black, and we're not going to have any trouble with those features. And as you can see here, here's the profile of that output, and this area here is the 1 millimeter gauge block. Here's the wood surface, and we'll just expand this a little bit. So here's the 1 millimeter gauge block, the wood surface, and here we're getting into the black plastic target material, and you can see that we're measuring those little artifacts really well. Got a couple little spurious reflections, but that can be filtered out pretty easily. So you can see that we're getting a very good signal. Let's go ahead and take a look at making the measurement, and we do have some 2D field tools here in the Acuity View software. So let's do a feature measurement, and we're going to add a new feature. And so with this, we're going to measure that step height to the 1 millimeter, and we're going to come and do some data processing on it. And so this is feature 1, and we're going to measure the height, and we're going to measure that average height. And here you can see that we're getting a value of about 1.15 millimeters, and that's probably due more to the fact that we have a probably off angle a little bit. Let's zoom this up so I can get to that slide bar. And so what we're going to do is we actually have a feature in here to tare it. So we're going to put in an offset of 1 millimeter. So we're going to force it to that 1 millimeter, and then we're going to tare. So now you can see we have corrected for this height measurement very accurately, and we're reading a millimeter. We also have a little result screen where you can see that a little bit bigger size. So you can see that we're on this tabletop, we're holding well within 3 or 4 microns, well within half a thousand sort of number. Let's also create another feature. We're going to add a new measurement. So now let's do the same thing, where we're going to come here on feature 2, and we're going to measure the height. As you can see, we can do distance or widths or heights or different positioning. So we're going to do a quick little calculation using this feature after we've calibrated the laser. And here you can see the number we're getting is about a 2.3 millimeter thickness of that material. Normally on process, we would probably recommend you have a laser line on each side of this moving material and do a differential measurement. Also, just real quickly, let's do one more feature. Let's see what that bump height is. So we're going to add another feature benefit. We're going to come in here, and that's feature 3. And you can still see all the measurements we're getting correctly. And we also want to do again height. And we're going to take some of the average of these measurements. So this is showing that we're getting about a 0.58 millimeter, a little over half a millimeter of differential between this point and this point. So that's sort of a proof of concept, a real static sort of image, that this is what the software would be doing real time. It would be looking at these sorts of features, and as you expand the box, then you can make these measurements. And here I've got it on a little linear slide, and you can see how the software reacts to changing heights of those. So let's come in and let's change this. Let's go ahead and clear all measurements off here. And so now let's take a look at a different feature on here. Let's clear this. And so now we're going to take a look at the 3D capability of this. And we'll move this a little out of the way. And as you can see, I've got it on a linear slide, and we've got it so every time I move it, I'm going to get an encoder measurement. And as you can see, as I'm scanning across there, I'm just going to go a couple times to build a little bit more dense data. And now I'm going to click on the static points. And so now you can see that we are getting a really good image of that part. I'm not seeing a lot of artifacts or noise coming off the targets, and you can see that we're getting very good definition. And let's see if we can highlight some of that. So here you can see the artifacts pretty clearly that we're making these measurements. There's the hole, and here you can see there's that 1 millimeter gauge block. Nice clean resolution on that change in target. So this is just sort of a quick proof of concept that we're able to measure this dark material without any problem, and even doing contrasting measurements at the same time using the Acuity AP820 laser sensors.